Okay, so next on our list are these three types of special kind of parallelograms. So our special parallelograms that we have are a rectangle, a rhombus, and a square. So let's talk about a rectangle. I'm going to zoom in on this so that way we can talk about it in a bit more detail as well. So by definition, just the geometric definition of a rectangle is a quadrilateral with four right angles. Okay, so as long as you have a four-sided shape and all four angles are right angles, it is considered a rectangle. Now, it has a couple of additional facts to it. Since it is a special parallelogram, it holds all the properties of parallelograms. There are how many properties of parallelograms? Four. What are the four? Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. But this one has an additional part. The additional part now is that the diagonals not only bisect each other, but the diagonals are congruent. So if we wanted to label this, okay, I need a 5-letter word, all with different letters. No. Like to name it. Oh, okay, we're going with that. All right. A, B, C, D, E. Okay, that'll work. We don't need a word. We'll just do letters. A, B, C, D, E. Okay, so now that we know that our diagonals are congruent, we can say for rectangles that AC is congruent to BD. The whole diagonals are equal to each other. Now remember that fourth property of parallelograms, which says the diagonals bisect each other, which means each part of the diagonal gets cut in half, or they're equal. But since they're all equal to each other, in a rectangle, that means that all four of those parts are equal to each other now. So since our diagonals are congruent, their diagonals are bisected, then they're all going to be equal, those four parts. So we end up with some interesting facts, and these are the main things that are going to help you solve equations that are in here. So you really want to pay attention and not be drawing extra things or writing extra things down on your paper. So you want to look at what kind of triangles are maybe represented here. If we draw on those diagonals, it splits our shape into four triangles, right? What kind of triangle is this one right here, this bottom one? AED. It's isosceles. So since the diagonals are created or are congruent, we create four isosceles triangles. Now, what does it mean to be isosceles? Two sides are equal, but also two angles are equal. So I'm going to throw in some angle measurements. I'm just making these up off the top of my head. Okay. So let's say, for example, this bottom angle here at A is 40 degrees. You can find every other angle in this shape just knowing that one. Because this is an isosceles triangle, then that means this bottom angle at D is also 40 degrees. Because it's a rectangle, each vertex is what degrees? 90. So if this angle is 40, the angle above it would be 50 to make 90. So we could put 50 here and here. Now if you turn your paper sideways, the triangles on the sides are also isosceles. So the angles up here would be 50 and 50. What does that mean the other angles at the vertices would be? 40 and 40. Now you can also find those four angles in the middle because the triangle, all the angles add up to be what? 180. So if these two down here at the bottom are 40, 40 and 40 make 80. So this top angle would have to be 100. And because of vertical angles, the other angle above that one would also be 100. What about the angle beside of it? Remember these two angles, this one here and this one here? It would be 80 because they are supplementary. They make a straight line. They're a linear pair. So this one would have to be 80. You could also look at your triangle. If these two are 50, 50 and 50 make 100. So we need 80 to make our 180. So again, just knowing one angle, we can find all the other angles. Now you may have things that deal with side lengths as well. So remember, in an isosceles triangle, two sides are equal. So that may help you find diagonal lengths. All right, let's talk about a rhombus now. So a rhombus is a quadrilateral with four congruent sides. That's the definition, okay? But it also has all the properties of a parallelogram. And we add on these two extra properties. The diagonals are perpendicular and the diagonals bisect opposite angles. So first off, what does it mean for diagonals to be perpendicular? 90 degrees. Good. It means that when they intersect, we are going to have a 90-degree angle. So all of these right here where they intersect together are going to be 90 degrees. So now we have made four right triangles. So in a rhombus, once you put in those diagonals, it makes four right triangles. Now the other thing that's true is the diagonals bisect opposite angles. What does it mean to bisect angles? Cuts it in half. So let's go with the same thing with 40. Let's say this one up here at the top is 40. Well, that means the one right beside of it should also be 40. And because this follows a parallelogram, we know that opposite angles are congruent. So these bottom two angles are going to be 40 and 40. Can I figure out the other two angles? Yes. If you think about maybe just one of these being a right triangle, you have a 40 degree and a 90 degree, so the other angle must be 50. So this one's 50, this one's 50, this one's 50, and this one's 50. So we end up making four congruent right triangles. Those would all four be congruent to each other because the angles there on the sides. Now, do we know that the diagonals are congruent in a rhombus? No, the diagonals are congruent in a rectangle. The diagonals in a rhombus are perpendicular and bisect the angles. So keep them separate. Rectangle, they're congruent in length. In a rhombus, they split the angles and make 90 degrees. So a rhombus is all about degrees and angles, and a rectangle, it's all about the length. Okay, now we're going to talk about a square. The square is the love child of the rectangle and rhombus. That's what it is. Rectangle and rhombus got together, they had a baby, and they named it square. Ta-da! There it is. Because a square, by definition, combines the definition of rectangle and rhombus together. For a rectangle, we have four right angles. For a rhombus, we have four congruent sides. And a square is a happy little marriage between. We have four right angles and four congruent sides. So, just like a rectangle, the diagonals, that's a new word. The diagonals are congruent. But just like a rhombus, they're perpendicular and bisect opposite sides. So it's putting the two together. It's their little love child that we have here. It has all the properties of a parallelogram, and it is a rectangle and a rhombus. So if we put our extra little comments to the side together, it makes four isosceles right triangles. So all of those things go together. Four isosceles right triangles. Since the diagonals are congruent in length, we can mark all of their parts congruent. So I'm marking these with 2 marks because I already have the sides marked with 1 mark. Then they are perpendicular, so we have right angles at here in the center. So not only do you have right angles around the outside, you have a right angle in the middle. Now the diagonals bisect the opposite angles, but in a square, all the angles are 90 degrees. So if you bisect 90 degrees, you get how much? 45. So all the angles around the outside are 45. So it makes 4 isosceles right triangles. Ta-da! Thank you. Y'all are so kind. All right, now there's also something else that we need to talk about, a review from Math 2, because we focused on isosceles right triangles in Math 2 when they are 45, 45, 90. If they are isosceles right triangles, you have 2 legs, right? And the legs are going to be equal to each other. So here's a leg, and here's a leg, and over here we have our hypotenuse. Now the hypotenuse is not going to be equal, but there was a little formula to help us get from the leg to the hypotenuse. You could use Pythagorean theorem if you wanted to set this up with different values. Notice that the legs are the same. Almost. It was the leg times. We did it along with, we didn't have a song for this one. We did have a song for the 30, 60, 90. This one didn't. But it was leg times the square root of 2 equals the hypotenuse. That was the shortcut to help us find it. But we also said you can use Pythagorean theorem. Just remember the legs are going to be the same. I think we had a little rap. Well, that was the 30, 60, 90. It said short leg times the square root of 3 is the long leg. Yeah, so that was 30, 60, 90. But we did a little rap with this one. We found one online. It was like, I can't remember. It was bad, though. I will try to make up a song. All right, but anyway, that's what you might need to know to help you solve some pieces that are in your square. But again, if you don't want to use the shortcut, you can use Pythagorean theorem. Remember, we like answers that are exact answers. So keep that square root of 2 in there if you have to. All right. Let's look at the examples that are on the sheet, the handout that I gave you. There's not too many of them, so we're going to go through those pretty quick, I think. So first, we need the most precise name for each quadrilateral. Now, if you notice, all of these have little arrows, right? So right now, all of these are what kind of shape? What do the little arrows mean? Parallel. So all of these are parallelograms. Let's see if we can name it a little bit more. See if we have any additional information. So what else do we know in this first parallelogram? All the sides are equal. What shape had a definition of all sides equal? Nope. Rhombus. What does a square have to have? Does this have right angles? No, this just shows all the sides equal, so the most precise name is a rhombus. Remember, we cannot assume 90 degrees. Okay, what about in question 8? All we have is opposite sides are equal, so we can rule out what 2 shapes? Rhombus and square. So is this a rectangle? By definition, what does a rectangle need? It needs 4 right angles. Do we have right angles? No. So it's not a rectangle. It's not a rhombus. It's not a square. It's just a good old parallelogram. All right. What do we know about the next shape? All sides are equal, so it's a rhombus. In 10, what do we know? 4 right angles, so it's a rectangle. Can we call it a square? No, a square needs 2 pieces of info, right? Because it's the love child of the rectangle and rhombus. We need 2. All right, here we have some true or false statements. All squares are rectangles. So when you see a true false statement or just a statement in general, assume the first part is true. We have a bunch of squares. Do squares have the same definition as rectangles? It is true. All squares are rectangles by definition. Because what's the definition of a square? 4 right angles, 4 congruent sides. So they already have the 4 right angles, which makes them all rectangles. Now, is the opposite true? No. Okay. Way to read those notes. That's right. Under square, it says is a rhombus and rectangle. So if it's a square, it's automatically a rhombus and rectangle. All right, let's go to the one below it. Every quadrilateral is a parallelogram. No, can you draw a 4-sided shape? Because that's a quadrilateral. So something that has 4 sides that is not a parallelogram. We're going to actually talk about this shape on Monday. But what about this shape? Trapezoid. Trapezoids are not parallelograms. All right, let's look at question 40. Some parallelograms are squares. Yeah, that's true. Some are not. All rhombuses are squares. No, that is false. And you could look at that example right up there. That's kind of blocked out now. All right, let's read through question 60. Which statement is never true? Square is a rhombus. Parallelogram is a square. Trapezoid is a parallelogram. A square is a parallelogram. Which one is never true? C, that's right. We just did that example kind of right there. Which statement is true for some, but not all rectangles? Opposite sides are parallel. It is a parallelogram. Adjacent sides are perpendicular. All sides are congruent. True for some, but not all. It is I. If all sides were congruent, it would be technically a square or rhombus, but it said for some, so some rectangles are also squares. A parallelogram has 4 sides. Which name 4 congruent sides? I need to read the whole thing. A parallelogram has 4 congruent sides. Which name best describes the figure? Trapezoid, parallelogram, rhombus, or square? C, rhombus. Which name best describes a parallelogram with 4 congruent angles? Rectangle. That's right. We can't say square for either one of those, right? Because the square has to have 2 things, sides and angles. Square needs both. Okay, let's look at the back of our handout and we will answer these 4 questions. Given quadrilateral ABCD with AB parallel to DC and AD parallel to BC, how would you classify the quadrilateral? Okay, well, first off, if I just know this information, this is a what? Is it a rectangle? It's a rhombus. Is it a rhombus? What's the only thing I know from the beginning? Opposite sides are parallel, so I only know that this is what shape? It's a parallelogram. Can I be more specific in the name? So these are 4 separate questions. So the first one gives us this information that AB, and what's that upside down T mean? Perpendicular to BC. So perpendicular means I have a right angle there at B. Well, if that's a right angle and this is a parallelogram, then opposite angles are congruent, and same side ones are supplementary. But in this case, if they're 90, then all of them are 90. So we know all the angles are 90 degrees. So what shape is it? Now it's a rectangle. Just knowing that that one corner is 90 degrees, since it's automatically a parallelogram, then all the angles are 90 degrees, so it must be a rectangle. All right, now question 2 is a totally different question, okay? So now we don't know anything about the angles. All we know now is that AD, which is this side, is equal to BC, which is this side. So all we know are those two sides are equal to each other. Are all 4 sides equal to each other? No. So we can take out rhombus and square. Can I say rectangle? Why not? We don't know about the angles. That's right. So what's my only choice? Parallelogram. Okay, now the third one, again, separate one. Now we're putting the first one together. So A, B, and B, C are perpendicular, so I can put a right angle there. But now we also know CD is equal to BC. It's a square because it's got now 4 right angles, and the consecutive sides, the sides that touch, are equal. So right angles and equal sides means square. Okay, now last one, so I'm going to erase all that. Last one says AB is equal to BC. Now it's a rhombus. Does that make sense on how to answer this now? So if opposite sides are equal, you have to say parallelogram because that doesn't tell us anything. If consecutive sides are equal, it could be a rhombus or square if we know about the right angles. All right, your homework tonight is a Google form that is on Canvas. You need to make sure that you submit this form before class on Monday, so that way we can go over the ones that are most missed. Remember, like the one that we did on Wednesday, if you don't type it in exactly like me, then it'll dock your score, but I don't care about your score. I just care about you submitting the problems. Okay, now leave your notes out as you go through because it's going to ask you a lot of questions like which shapes have this property, or what does this and what does that. So you need to leave them out so you can match them up. Nope, you don't have to turn in anything on paper, but you probably want an extra sheet of paper, or you can use the bottom of your note sheet to work out some problems, especially ones that give you a shape and then tell you to find things. Now, one extra thing that I want to tell you is that when you name a shape, remember you have to go in a circular order. So if I were to name this shape, it would be A, B, C, D. I would not say A, B, D, C, because that's not in the right order. So when you see your homework problems tonight, it may tell you to draw the shape yourself, but remember the letters go in a circular order. So if you don't put them in the right order, you're going to mess up your answer. Okay.